Hi everyone. So today we're looking at function transformations, and this is sort of a standalone topic that can apply to lots of different types of functions. We've looked at this a little bit with quadratics already. We've done some translations, but we're going to talk about other types of translations and other types of functions here. The first type of transformation we're looking at is the translation. And a translation is when you're moving a function or moving a graph around by sliding it. So you're not changing the shape, you're just changing the position. So a slide that's left, right, up, or down. I think that's specified for you here. And the way you accomplish that mathematically is with addition and subtraction. So we're going to be writing rules for these transformations. And this type of transformation looks like this. It's going to take a coordinate x, y, and change it by adding something to x and or adding something to y. So x plus h, y plus k is how we're going to write this. And I just want to point out that subtraction is okay too, because h and k are allowed to be negative. Okay, and you'll see an example of that. Like if you look down at the first example here, this is what I'm talking about, is we're taking a coordinate and we're changing it using this rule here. Okay. The next type that we're looking at is a scale change, and a scale change is accomplished with multiplication and division. So we would say SXY, and the S is just for scale change. And we're going to take the X and multiply by something, and we're going to take the Y and multiply by something. And we use A and B here typically. And just like before, we can also divide because we can think of that as multiplying by a fraction. And then the last one on our list is the reflection. And the reflection is technically considered a type of scale change, and I'll explain why later. So if we take X or Y, the way we make things flip over an axis is by using a negative sign, okay? So, and you wouldn't have to have it on both, but you could have a negative on X and or a negative on Y, and we'll talk in a little bit about, which one moves which way. Okay, so looking down here at this example 1, it says describe the effect of this transformation. And it's addition and subtraction, so we know it's a translation, but we have to think about, what specific type of movement is going to happen here. So anything that's happening to X is going to be a horizontal movement, meaning we're going to be moving left and right, okay? Anything happening to Y is going to be a vertical movement, so we're going to be moving up and down. So I would look at this and say, well, if I'm doing x minus 4, subtracting 4 on the x-axis is going to move me to the left. And adding on the y-axis, if you think about how you move on the y-axis, it's up and down, and addition would move you up. Okay. Okay, the scale changes, these are going to be stretches and shrinks. So these are going to be making graphs wider or skinnier or taller or flatter. And just like before, anything that's happening to X is going to be a horizontal change of some kind. And if we're multiplying by 2, really what we're doing is we're making it 2 times as large horizontally. So what we would call that is a horizontal stretch. It's a stretch because we're multiplying by 2 by a factor of 2. Okay, now with the Y, what's happening is we're dividing by 4. So dividing is going to make something smaller. That's going to be a shrink, and that's going to be a vertical shrink because it's happening to the Y. Now, I didn't do anything with the negative, and there's a reason for that. So vertical shrink by a factor of 4. And then the last piece of this is that negative sign there, okay? And if you have a negative on the y value, I want to just look real quick at what this is going to actually do to your graph, okay? So I'm going to sketch a coordinate plane here. And let's say you have this coordinate here, I don't know, 2, 3, okay? And then you come along and you put a negative on that y value. So you want to do a 2, negative 3. That's going to be still 2 to the right, but the negative 3 is going to take you down 3. So this would be 2, negative 3 down here. And so if you look at the type of movement that occurred, we flipped vertically, which makes sense because that's on the y, right? So that's going to be a vertical flip. It's flipping up and down, okay, when you make the y value negative. So I would just say it that way. I would just say this is a vertical flip. Okay, that's the easiest way to do it because it kind of keeps in line with everything else that's horizontal or vertical. I do want to point out what some people say is they say, well, this here is the x-axis. And so what really happened is we flipped over the x-axis. We hopped over the x-axis. So sometimes you'll also see this written as a flip over the x-axis. And that's totally okay if you write it that way. In fact, I think it shows up written that way in some of your homework assignments. The only problem with that is this gets a little confusing. We're flipping over the x-axis even though it's on the y. Okay, and that's just because the x-axis is your horizontal line that you would have to jump over to do a vertical flip. So in that regard, this is kind of opposite from what you would think it would be. If it was a negative on the x, it would move this way. Okay, which is a horizontal movement, but it's jumping over the y-axis. So just kind of keep that in mind. Okay, couple of definitions and things like that here for you. And if you need to pause the video to write them down, please feel free. So to be able to do transformations, we really need to understand what we're starting with. And when you do a transformation, you always start with something called a parent function. Okay, a parent function is like the original function before you've applied any transformations to it. So as an example, the most basic like parabola you can think of is y equals x squared. That's just a nice normal looking parabola that's going to be sitting right at the center of the graph. Okay, it hasn't moved anywhere, it hasn't stretched, it hasn't shrunk. That's like your original base parabola. Okay, and then when we start throwing other numbers into that equation, that's when our graph moves around and shrinks or stretches or whatever. Okay, you could also have a parent function of, let's see, what are some other functions we've talked about? A basic linear function would be just y equals x. I know usually linear functions are mx plus b, but the m and the b, those numbers are causing transformations to happen. So the basic linear function would just be y equals x. You could have the basic absolute value function, y equals absolute value of x. And then when I put numbers on either side of that equation, again, that's when your transformations occur. So what's going to be happening here is we're going to be given equations that look like these parent functions, and then we're going to be given these rules, and we're going to apply the rules to the equations. But there's one thing that's tricky about this, and I'm not going to get super deep into like the reasoning behind this, but when you have a transformation and you're applying it to a parent function, everything goes in backwards, okay? So in the rule, if you see addition, you put it in as subtraction. Okay, if you see division, you put it in as multiplication. It has to do with the fact that the equation is trying to like compensate for things. It'll be easier if I show you that in class. I can show you a demonstration for why that happens the way it does. So if you look at this first question here, this rule is the very same one that we started with. Okay, the first example we did x minus 4y plus 3. We said it would move left 4 and up 3. Now we're actually going to put that into a y equals x cubed graph. Okay, so what I'm doing here is I'm removing the x from the equation and I'm replacing it with an x plus 4. I'm replacing it with the opposite. So here's my original y equals x cubed. And what I'm going to do is I'm going to take out the x and put an x plus 4 in its place. Notice how I put that in parentheses. I'll talk about that in just a second. That'll still have a cube on it. And then I'm going to take out the y and replace it with a y minus 3. Okay, so this, what's written down here in pink, and I'll write it off to the side so that it's a little more clear, would be my final equation. Y minus 3 equals x plus 4 cubed. Okay. And if you were to go graph that, you would see that it looks just like y equals x cubed, except it has been shifted to the left 4 and up 3. Okay. The reason I use these parentheses here is we need to make sure that our transformations are being applied directly to the variable that they go with, okay? If I put it outside of the parentheses, if I wrote like x cubed plus 4, for example, the 4 wouldn't be applied before the cube. And so parentheses are the easiest way to say, hey, do this first. So really, especially with the x, anything that you're doing to the x through a transformation, you're going to want to put in parentheses like this. Okay. Oops. So my next one, I'm still working with x cubed, and this time I have x divided by 2 and negative 3y that I'm putting in there. And same as before, I'm doing this by replacing the x and the y. So I'm starting with y equals x cubed. Oh, didn't mean to change the thickness there. Okay, and I'm going to take the x out and replace it with an x times 2, because remember I'm doing the opposite of this. So I'm going to say this is now a 2x that's being cubed, okay? And I'm going to take the y and replace it with a y divided by negative 3. And there are some times that you'll see like these equations written with this negative 3 moved over to the other side. You know, that's a more technical way to do this. For what we're doing right now, I am totally okay with us just leaving our answer this way. Okay, so we're just going to leave it like this. Okay, and last question says, give an equation, but this time it gives you a description of what's happening rather than a rule. My suggestion would be to write the rule first. Okay, so let's figure out what the rule is here. So flipping over the y-axis, again, if I think about visually, this is my y-axis. So flipping over that is a horizontal flip, meaning that's a negative on my x value. So in my transformation, it's going to be xy. And I know that my x value is going to become negative because that's how I'm going to flip over the y-axis. And then shifted down by 2 units. So shifted means adding or subtracting. The fact that it's down means it's going to be subtraction. And it's going to be on the y because that's what moves up and down. So I'm going to say y minus 2. So that's my rule. Now what I want to do is put that into my equation. So once again, I'm starting with y equals x cubed. And I'm doing the opposite of what I just wrote in my rule. It's helpful to have the rule in front of you because that kind of controls everything. But when you put it in the equation, it's going to be opposite of that. Now, I say that. The exception to that is the negatives. Okay, the negatives don't really flip and do anything different because multiplying by a negative and dividing by a negative is the same thing. So my negative on my x is still just going to stay a negative x cubed. Parentheses are important there. My y minus 2 is now going to be a y plus 2. And if you graphed this equation next to this equation, the y equals x cubed, I would see that these graphs are horizontal reflections of each other, and this one would be shifted down too. Okay, let's keep going. First thing I'm going to do with this one, just to make this a little bit easier to understand, this is 1/3 times x, which is multiplication. Normally we would think of that as a stretch, right? But multiplying by a 1/3 is really the same thing as dividing by 3. And so I'm going to think of this as an x divided by 3 because I think that'll be easier to work with in my equation. Okay, and then negative 2y. My function is 1 over x squared. So I'm going to be focusing on how am I changing the y and how am I changing the x. And the rest of that equation, kind of the skeleton of that equation, is going to stay exactly the same. So when I see x divided by 3, my brain is saying, okay, I need to multiply by 3, right? And I need to take this x and multiply it by 3. So this is going to be a 3x instead of an x now. It's going to be squared still, in parentheses. The 1 on top stays there. And then this is still equal to whatever's happening over there with the y. So I just took my x out and replaced it with a 3x. Okay? Okay. Now let's look at what's happening with y. Y is being multiplied by -2. So in our function, we want to divide by -2. And so I'm going to write this here as y divided by -2. And again, are there cleaner ways we could write this? Sure. But right now, this is all I care about, is that you can put the numbers in the correct places. And the last one, the equation of this function shifted 1 to the left and flipped vertically. So again, the first thing I'm going to do is make my rule. I'm going to figure out what does this mean is happening. I really need this in this format before I can start doing one of these problems. So I'm going to say xy is changing to, let's see, 1 space to the left. Okay, so shifted, that's a translation. So that's adding and subtracting. If it's going to the left, that means it's working on x because it's horizontal. And it's subtraction because that's how we move to the left. So we're going to say x minus 1. A vertical flip, that's an up and down flip. So that's a negative sign on the y value. And now I'm putting that stuff into my equation, but I'm putting it in as the opposite. So my x, what I had here, is now going to be an x plus 1. So I'm going to start with that. X plus 1. It's still going to be squared because it was squared in the original equation. It's still going to have the 1 on top of it. And then over here, remember the negative signs still just stay negative signs, so this would just be negative y. Okay, so we're going to try a few of these tonight. We're going to practice this some more when I see you in class the next day. And this is really your goal. Like these types of examples, this is really what I want you to be able to do for right now. I mean, this is a much bigger topic, but right now I just want you to understand what numbers or what effect these numbers have when you put them into the equation and how to make certain things happen. So, all right, thanks a lot. Have a great day.